A very good day to Doctor and fellow friends. Today, Group 11 will be presenting Fire Hazards and Life Safety. The group members are Jia Wei, Cornelius, Pok Lian, and myself, Heshni. As we all know, fire is a chemical reaction that gives off light and heat. It is also involved a chemical process. There are three elements that are required to start and sustain a fire, which is oxygen, fuel, and heat. These are the compulsory conditions that favor fire development or even growth. Okay. As we all know, fire is also useful, but also very dangerous because it can burn houses, trees, and many other things into ashes. This is why fire is hazardous. It is very harmful, destroy a huge area in a matter of minutes, and people could die from accident because of fire. And since oxygen is naturally present in most Earth environments, fire hazards are usually involved the mishandling of fuel or heat. Okay. To be remembered, fire or combustion is a chemical reaction between oxygen and combustible fuel. And when it comes to combustion is a process by which fire converts fuel and oxygen into heat. And also we can call it as heat energy. Okay. Through ignition or combustion point is the temperature at which a given fuel can burst into flames. This is why it is called fire hazards. Next, we will move on to type of fire hazards. Okay, there are two types, which is exothermic and endothermic. Exothermic means chemical reaction that create heat, such as combustion and fire, that is mentioned earlier. And endothermic means chemical reactions that consume more heat than they generate. Example like evaporation. Okay. For exothermic process, it will involve making of ice cubes, formation of snow in the clouds, a candle flame, and so on. While for endothermic, it will be usually melting the ice cubes. For exothermic, it will be making the ice cubes, while endothermic will be melting the ice cubes, evaporation of water, making a break, and so on. Okay. So through this, we can see that all chemical reaction involve formation and destruction of chemical bonds between atoms. Okay, for an example, carbon is commonly found in most flammable materials. Okay, when we burn a thing, carbon is released, which is combined with oxygen and form carbon dioxide. As we can see, there are two types of carbon that is released, which is carbon dioxide and carbon monoxide. In carbon dioxide, it is formed when there is more oxygen than the fire needed. While for carbon monoxide, the incomplete combustion due to lack of enough oxygen to support combustion. Okay, so this is part of type of fire hazards. Next, we'll be seeing fire chemistry, which is the fire tetrahedron, also known as the fire reaction. Okay. Remember, for fire to continue, there must be a constant source of fuel, oxygen, and heat. And when the flaming mode is represented by the tetrahedron, that results from a chemical chain reaction. And any removal of any one element extinguishes the fire. Which means, kalau terdapat kekurangan elemen, dia akan padamkan api tersebut. Okay. There are some principles to be remembered, which is enough oxygen to sustain combustion, enough heat to raise the material to its ignition temperature, and some sort of fuel or combustible material. These principles are made to maintain or heat up the fire. In this slide, we will be seeing some combustible material that is used to light up. The first one, which is EPDM rubber, which is known as ethylene propylene diene monomer rubber. And the next one is PE foam, polyethylene foam. And the next will be PU foam also, flexible polyurethane foam. And the last will be NBR or PVC, which is nitrile rubber or polyvinyl chloride. Moving on to the next, which is heat transfer. Heat tends to flow from a hot substance to a cold substance, which is law of heat transfer. Okay, there are three mechanisms that have been focused, which is conduction, radiation, and convection. Okay, first we'll be looking at conduction. Okay, conduction is a direct thermal energy transfer, which is heat to cold, and the materials are near a source of heat absorbed. Ambient heat raising their kinetic energy, and it usually occurs when a body is heated as a result of a direct contact with a heat source. Okay, and the primary cause for fire spread early in fires. Okay. Conduction also makes the fire spread by heating a pipe in a room and starting a fire in another room. Okay, usually when we touch a hot object, right? So that's how a conduction happens. Okay, and usually for radiation, moving on to radiation, it is not a nuclear invasive and it is electromagnetic transfer of heat. It usually transfers the heat from one mechanism to another through heat transfer itself. Okay, so transfer of heat energy without intervening the medium. For an example, by holding your hand to the side of a candle, and there are major problems that is frequently what causes a fire extension to other buildings. Okay, and the third will be convection. Convection is a heat transfer through the movement of hot gases or liquids via some mediums such as air, water, and so on. Okay, this convection usually determines the general direction of a fire spread. Okay, the convection causes fire to raise as the heat rises and moving into a direction of the prevailing air currents. Okay, as you feel the heat, you feel when your hand is above a candle. Okay, the heat usually produces the thermal layering, and it also can cause fire extensions between floors and so on. For further details of heat transfer, which is mainly focused on convection, the thermal layering. We are focusing on the thermal layering now. Okay. So the thermal layering of gases is the tendency of gases to form layers according to the temperature, which means there will be several layers according to the temperature, and the layers will be acquired like hottest gases tend to be in the top of the layer, while the cooler ones will be in the bottom of the layer. Okay, so smoke is a heated mixture of air, gases, and particles, and it rises. And if there's a hole is made in the roof, the smoke will rise from the building to the outside. This is part and parcel of heat transfer focusing on the convection.
Now I will continue the presentation with the fire terminology. So the first one is the flash point. So the flash point actually is the lowest temperature at which the ignitable concentration of the gas that will burn. The second one is the fire point, which is the minimum temperature at which the vapor will continue to burn. The third one will be the auto-ignition temperature, which is the lowest point at which the vapor of a liquid or a solid will self-ignite without a source of ignition. The fourth one is the flammable liquid. So the flammable liquid is a flash point which is lower than 100 Fahrenheit or 37.77 degrees Celsius. The fifth one is combustible liquid, which is the flash point at or greater than 100 Fahrenheit or 37.77 degrees Celsius. Moving on, we can classify the fire into the four classes. So starting from the class A. So the class A fire are the most common type of fire. They are produced from a common combustor material, including the wood, paper, fabric, rubber, and plastic. So the class A fire have a relatively low ignition temperature, and once the fuel of oxygen has been depleted, the fire will burn out. So a garbage fire is one of the example of the class A fire. So the class B fire occur when the flammable liquid or gases such as the alcohol, kerosene, paint, gasoline, methane, oil-based coolant, or propane ignite. So the class B fire are most common in industrial setting, but they may also occur in residential and or commercial setting. So the class B fire have a low flash point, which means that they burn easily at any temperature if exposed to a fire source. So the class B fire also spread rapidly and also produce a thick black smoke as they burn. Class C are those fire that have a live electrical current or electrical equipment as a source of fuel. So such fuel source could include electrical tools, appliances, a motor, and transformer. So Class C fire are most common in industrial setting that deal with energy and electrical power equipment like the wind turbine. So, however, the Class C fire can also occur in commercial and residential settings due to the issue like faulty wiring. Class D fire describe those fire that occur with a combustible metal fuel source. So, common combustible metals include aluminium, lithium, magnesium, potassium, titanium, and zinc chromium. So this type of combustible material are most often used in laboratory and manufacturing. So the biggest danger of Class D fire occur in this industry. Next one, we will look at the identification of fire hazard. So the first one is the NFPA, also known as National Fire Protection Association. So this standard presents a simple, readily recognized, and easily understood system of marking, so commonly referred as an NFPA hazard diamond, that provide an immediate general sense of the hazard of a material and the severity of this hazard as they relate to the emergency response. So the identification of systems specified in NFPS 704 is intended to enable the first respondent to easily decide whether to evacuate the area or to commence emergency control procedure, and to also provide information to assist in selecting firefighting tactic and emergency procedure. The NFPS 704 hazard identification system is characterized by a diamond, which is more precise defined as a square on point shape. So identify the degree of severity of the health, flammability, and instability hazard. So hazard severity is indicated by a numerical rating that range from 0 indicating a minimum hazard to 4 indicating a severe hazard. So the hazard are arranged spatially such that the health hazard are indicated on the 9 o'clock position, the flammability at the 12 o'clock position, and instability at the 3 o'clock position. The 6 o'clock position are the symbol represents special hazard and has a white background and is not always filled. Looking at the example of this picture, we can see that on the left side is the health hazard indicated by blue, the right side is instability by yellow color, the top side is fire hazard indicated by the red color, and also the bottom side is the specific hazard indicated by the white color. So we can see on the downside table, we can see that each type of rating starting from 0 to 4 for each of the hazard indicate a specific explanation for it. So 0 means that they have the minimum or less hazard, while the 4 indicate a very severe hazard for each of the criteria. In this table is some of the example according to NFPS 704 system for the specific information. So we can see that each type of symbol represent a specific of information that will told to the first responder about what is type of the hazard is. So like for example, the acid, so means that this material is in an acid type. If the word state ALK means that this is the alkaline base. If COR means that it is a corrosive material. And the last one indicate that this a type of symbol with circle and also the three triangle is means that the material is in radioactive.
My name is Pok Lian and my metric number is 2788942. I will present the detection of fire hazard. The first is thermal expansion detectors, head detectors. This detectors is a normally open device designed for fire detection and alarm system. This detector will trigger an alarm or sprinkler. This detector operates on the principle of a rate compensated detector. The detector consists of a high expansion aluminum tube which encased two insulation struts with opposing open constant points. The high expansion sensing shell and the expansion struts have a different coefficient of expansion. A slow rate of temperature rise allows the head to penetrate the inner expansion struts. Therefore, the tubular shell and the struts expand slowly until the total device has been hit to its red temperature level. At this point, the silver contact point closed which initiated the alarms. When the surrounding air temperature go below the red temperature level, the shell contract which force contracts to open, which automatically resets the detector. The second is photoelectric fire sensor smoke detector. Photoelectric smoke alarms are generally more responsive to fires that begins with a long period of smoldering, called smoldering fires. How they work? Photoelectric types alarm aim a light source into a sensing chamber at an angle away from the sensor. Smokes enter the chamber and then reflecting light onto the light sensor and triggering the alarm. The next is an ionization or radiation sensor smoke detector. Ionization smoke alarms are generally more responsive to flaming fires. How they work? Ionization type smoke alarms have a small amount of radioactive material between two electrical charge plates, which ionizes the air and cause current to flow between the plates. When smoke enters the chamber, it disrupts the flow of ions, thus reducing the flow of current and activating the alarm. The next is ultraviolet or infrared detectors, head detector. A systematic of a variable wavelength detector. Light from a lamp is directed through a slit onto a diffraction grating, which spread the white light into its various wavelengths. The grating is rotated to direct the desired portion of the spectrum through another slit. The light is then directed through the flow cell onto a photodiode. As sample pass through the flow cell, the amount of light transmitted to the photodetectors is reduced, and this difference in transmittance is converted into the detector output in absorbance units. Commonly, a beam splitter is included, directing part of the light to another photodiode. This configuration allows the electronics to make correction for fluctuation in the lamp intensity and thus improve the optical performance of the instrument. The passive infrared PIR sensor are used in thermal sensing application. They are commonly used in security alarms, motion detection alarms, and automatic lighting application. Passive infrared PIR sensors use a pair of photoelectric sensors to detect heat energy in the surrounding environment. These two sensors sit beside each other, and when the signal differential between the two sensor change, for example, if a person enter the room, the sensor will engage. That may mean it triggers an alarm or notifies authorities. IR radiation focus on each of the two ferroelectric sensor using a series of lenses constructed as the sensor's housing. These lenses widen the device sensing area. That's all for me. Thank you.
Good morning, everyone. My name is Cornelius Chang, matrix number 271750. Now, I would like to present on reduction of fire hazard. So, for the first step is proper storage of flammable and combustible materials. So, example is we should store flammable materials away from incompatible materials. We cannot put at place that exposed directly to sunlight or hot temperature, such as in the car. So the next example is store flammable liquids that contains gasoline and alcohol at a lower room temperature. Then we should also make restrictions on the volume, how much of product that can be stored. So the second step is substitute with non-flammable or combustible material. We should replace candles with emergency lights, or we can replace gas stove with electronic stove. And then the next step is separate ignition source from fuel. As example, when we go to petrol station, we cannot smoke when we fill the fuel, and we also cannot using phone during at the petrol station. And then the next step for reductions of fire hazard is we should prepare, our company should prepare fire extinguishing equipment. So a company should prepare fire sprinkler system, which serving as the first line of defense against sudden fire. And then a fire sprinkler system provide enough water to suppress the flame before going out of control. They offer safe protections and giving extra time for a safe evacuations of the building. And then the next step is the company should prepare fire hose cabinet, water fire extinguisher. The company should also prepare fire alarm systems such as fire bell, which can give an early warning before the flames go out of control, and it can protecting life and property. Also, the company should provide beam detector, which is a device that operates by detecting smoke using a projected light beam. The optical beam detector does not work until the smoke reach the device mount to the ceiling. The detector is attached to an alarm system. So when the beam detector detects the smoke, the alarm system also automatically will send the warning to around the company. Other methods of reduction of fire hazard, the company should prepare a emergency response team called ERT, and then the company should also provide a disaster preparedness training for all the employees. And then the last step is prior prevention strategy, where the company can prepare a smoking zone for the employees, and the company should test smoke alarm frequently. Also, the company must inspect heating source to ensure safety. And then the company can also build employee awareness and training program. So in this chapter, there is a law normally used, which called Uniform Building by Law 1984, short form UBBL. So UBBL is a principle prescriptive by law which directs and influence one building design in order to protect the life, health, and safety of the individual who will later inhabit the building or structure on it is complete. So this Uniform Building by Law 1984 normally used by architect who design and structure the building. So the next one is mean of egress. and FPA 101. So mean of egress is a model codes that developed by the National Fire Protection Association and FPA, which highlight the fire protection and life safety. So the definition of egress is called the action of going out or leaving a place. Based on mean of egress and FPA 101, so the first thing highlighted is the doors. The design of the doors should be side hinge or pivoted swinging, and then the doors must swing in the direction of exit. The door should also readily open from the exit side. Then the door must be provided with a knob, panic bar, or other simple type of releasing device having an obvious method of operation under all lighting conditions. And then this model code's mean of egress also highlighted the egress capacity. Egress capacity for an exit route is determined by figuring egress capacity for each egress component and determining the most restrictive component in the exit tour. So the egress capacity fit factor for a stairs is 0.3 inches per person, and for ramps and level component is 0.2 inches per person. Okay, the third thing highlighted in the mean of egress is the number of egress, number of exit. So based on International Building Code called IBC, it highlighted or it requires at least two mean of egress to exit from all space and buildings with few exceptions. And then some space and building are allowed to have one exit or one mean of egress if the travel distance to an exit is short and the occupant load is low. The mean of egress is made out of three parts based on the picture below. So the first one is the exit access, the second is the exit, and then the last one is the exit discharge. Exit access includes all travel within occupied areas of the building leading up to an exit. The fourth thing highlighted in the mean of egress is access to exit. Access to exit should continuous and unobstructed way of egress travel. Then the maximum travel distance to at least one exit shall not exceed 150 feet in buildings not sprinkled or exceed 200 feet in buildings protected throughout by an approved supervised sprinkler system. And then the fifth thing highlighted in the mean of egress is impediments to egress. Access to an exit must never be through a kitchen, a storeroom, a restroom, a workroom, a closet, a bedroom, or any other comparable location. Exit access doors leading to exits must also be structured and constructed to be easily identifiable. The next thing highlighted in the mean of egress is marking mean of egress. Any direction of exit access must be able to see an approved sign clearly marking all exits and access method. Each sign must be placed in a prominent location, be of a size, color, and design that stands out and contrasts with other signs, interior finishes, or other decorations. And every sign must be properly lighted by a dependable light source. Signs that are internally and externally illuminated must be visible in both regular and emergency lighting modes. And then the next thing highlighted in mean of egress is emergency lighting. Emergency lighting must remain on during a loss of normal utility powers. All emergency lighting must be installed and tested in accordance with an FPA 111, which highlighted full 1.5 hour test annually and 30-second test every 30 days. For the last part is life safety inspection by company. So what the company should do is for the first one is prepare a fire door. The second is prepare a flame resistant clothing. The third is life safety program such as fire drill. And then the next one is cross functional fire safety committee. And then the next one is evaluation of the program, fire emergency plan, and the last one is awareness of prevention through training program.